So last time we derived the expression for the Gauss law which reduces to a point form, that is del dot D is equal to rho or rho B. What is del? Del is deba by deba x. To be very precise, it's half expression. It's half expression. So it is to be understood appropriately, otherwise it is incomplete. Only del that way may not have any meaning as such, but means only del does not have any meaning. It has to work on either a scalar or a, that is gradient, or a vector in dot product form or cross product form. So it is ax deba by deba x. Don't write it is afterwards, otherwise you will be jumble that whether it is deba x upon x. It's not like that. Plus ay deba by deba y plus az deba by deba z. This is a vector where it is to be very precise, it is representing directional differentiation. What is del operator is a differential operator in direction. So it's a vector whose x component is deba by deba x, which works, means to be very precise, what is del? Means just like what is d by dx? dy by dx. So it has to operate on some y. It has to operate on some y. Similarly, when we talk of only derivative, what we have got? We have got the independent variable x and dependent variable y, or independent variable t and dependent variable y. So we say deba by, or since it is only one, we don't go for deba, we go by d by dt of y, dy by dt. Whereas when we think of the spatial independent variable, so when independent variable is space, listen very carefully, when independent variable is space, say for it means merely because of only del operator, if I say like this, then when I say its dot product is dx x component ax plus dy ay plus dz az. So this is a vector d, that is the electric flux. At every point it is having some magnitude and some direction, with its components, projections on three coordinate axes are dx, dy, dz. While writing, ax is deliberately written before than deba by deba x. So, and that corresponds to the volume charge density. It is the del dot D is rho. Means last time what we have derived? We have derived that rho v dx over a small surface, rho v dx dy dz is equal to what it corresponds to? Rho v dx dy dz. What was the last derivation? That time we found that it is, what is that? We concluded and made, whether anybody is having that written, that is there? That is the on six faces we said that when we talk, if we talk like this, D on right hand surface and d on left hand surface. D on right hand surface, d on left hand surface into, there was dy dz. Then what we did? D on right hand surface is equal to d on, we don't know what these are. D on right hand surface is equal to d on left hand surface plus, since the distance between left hand surface and right hand surface is negligible, I am trying my level best to explain to you. Let us say that you were at some position at 10 am and at 10:15 am, at what position you will be? That you will calculate with what speed you were moving into 15 minutes. But here there is a presumption that speed remains constant, which may not be wrong, which may not be correct. So listen very carefully. The last part of the derivation, if you have noted down, or if you have not noted down, I will put on YouTube and you can view it again. D on left hand surface and D on right hand surface. D on left hand surface, D on right hand surface is equal to, can I write this? D on right hand surface is equal to D on left hand surface plus something that I can anyway write. Is it just like D on right hand surface is equal to D on left hand surface plus something. But then what is the point? I mean, it's just like suppose if nowadays after pandemic, the oral examination syndrome is substantially reduced. Otherwise, we observe this phenomenon that in oral examination, what students try to do? Just try to twist the things. D on right hand surface, D on left hand surface. So what is D on right hand surface minus D on left hand surface? That is, I don't know that. So what I do? I say that D on right hand surface is equal to D on left hand surface plus something. Means by saying plus something, I am just rewriting the question and not giving the answer. So when I say that now D on right hand surface is D on left hand surface plus something, then D on right hand surface minus D on left hand surface is something. Now, whether that something with what I say, this was unknown, the difference is unknown, then if I am able to describe the difference in somewhat clearer form, means what is learning, what you are doing, you look here, moving from vagueness to clearness. Then she might not be looking at the whiteboard because she may be thinking that if I listen, movement from vagueness would be to ultra vagueness. That is also likely. So that what that something is listen very carefully, the difference of the electric field D between left and right. Now, what is rate? Rate means rate with respect to something. So, if I say that position, I say depends upon speed. What is speed? Position at some point of time minus position at some other point of time upon the difference of the time. But that is also not giving me clear information because that speed may not be constant throughout that time difference. That may change. When that becomes meaningful, if the time difference is substantially small, if the time difference is substantially small, this is called as piecewise linear approximation. If the time difference is substantially small, then I can presume that throughout that time it is constant. The difference is negligible, means difference of change is negligible. So I can very well say that D right is equal to D left plus delta D. Delta D means right equal to left plus something. Then this delta D, and what is the difference between left face and right face? The distance is delta x. The distance is delta x. Right. If delta x is sufficiently small, then I can write delta D. If delta, I am trying my level best. I don't know whether it's meaningful. If it is meaningful, if it is not meaningful, then the further question is redundant. If it is meaningful, is it useful? So, if both answers are y, then there is some purpose served. So, delta D, I can say approximately equal to, what can you write what this would be? What that would be? What would be in bracket? What that would be? And it is, I think, we are talking about, when we are talking about the phase, we are talking about x component, right? Why? Because the area vector is yz plane. So it is not just d, it is dx, right? So delta dx would be what? Can you write something here? What? No, that. So what it means, what we are doing? That एक फॅक्टर पाडायचे पुन्हा मल्टिप्लाय करायचं, तुला तेच येते. What this would be? Delta dx is the difference in x component of electric flux on the right hand surface and left hand surface. Right hand surface and left hand surface differ in x direction by negligibly small quantity delta x. What this would be? What? Not rho v. With this hint, can somebody think further? Some? This will be some derivative. What is that? It will be d dx upon dx. So derivative changes from point to point. If I have a curve, its slope changes from point to point. Its slope changes from point to point. If you want to find out to what extent you increment in a y direction for a given increment in x direction, for that small delta x, delta y would be slope at the middle into delta x. Is d dx by dx. However, why this d changes to delta? So del, multiple del delta d, confusing this dabba dx by dabba x. What is the reason? Because the other things are constant at time. So I am only, since I am going to differentiate on y and z also, here I am writing dabba by partial derivative. Means y and z are otherwise variables, but in this case they are constant. So dabba dx by dabba dx. So this dabba dx by dabba x, delta x. The other becomes, so this into, so what you had in the term, this was added and plus already we had delta y delta z. So similar terms are added everywhere. So on the left hand side we had rho v delta x delta y delta z. So delta x delta y delta z goes from all the terms and we get rho v equal to dabba dx by dabba x plus dabba dy by dabba y plus dabba dz by dabba z. So that dabba dx by dabba y, dabba dx by dabba dy by dabba y, so dabba dx by dabba x plus dabba dy by dabba y plus dabba dz by dabba z is represented by this formula. It is del operate means is as good as multiplication, is as good as multiplication of, it is, I am repeating the word as good as, means dabba by dabba x into dx is actually not that way multiplication. So this is what we can say one kind of virtualization. Well, you will say then del dot d, if there is a vector, suppose that this is one x2, where is he? I think, let us see. He is extraordinarily alert. And a novice teacher comes to your class and he says that yes, del dot d is equal to rho. Then do you means to do mischief also you must be competent. To have a meaningful mischief, not a casual, what we can say, high school level mischief. So, del dot d equal to rho v. So, it is a dot product of del and d. So, can a very smart student put a very challenging question to a novice teacher just by looking at this equation? So, this is what? Dx x component, dy y component, dz z component. Then, if I say like this, then I can look it as dabba by dabba x into dx, means something into x component of dx plus something into y component of dy plus something into z component of dz, something into x component of d plus something into y component of d plus something into z component of d. So to each component when you multiply something in a dot product, so that something, so dx is x component of d, dy is y component of d, dz is z component of d, then dabba by dabba x is x component of something, dabba by dabba y is y component of something, dabba by dabba z is z component of something, and that something is del. Ax dabba by dabba x. So this is del and this is d. Del dot d. So dabba by dabba x into dx. Then any mischievous question? This is means I am again repeating, mere del is, to be very precise, everything you will say that everything is imaginative, nothing is real in this subject. But even if we are in the imaginative domain, del is one further step away. That is, del is a dream in a dream. So, based on dot product, can a mischievous question be asked which will make the teacher confused? Del dot d equal to rho. Whether means associativity, commutativity, all these things you must have heard. So based on that, can you put a mischievous question? Whether dot product is commutative? Whether dot product is commutative? A dot B, if A is a vector and B is a vector, A dot B is equal to B dot A. then will you put D dot del? D dot del? Why? D dot del. So dx operating on dabba by x is something which doesn't make sense. So del means try to understand the del dot d, that is the dot product of del operate a directional derivative differential operator and a vector field. So this del is a virtualized vector. This del is a virtualized vector. It, just like what we can say, that it does not have an just like ammonium, NH4 does not have its independent existence. It has to be either with ammonium chloride, ammonium sulfate, like that. So this del doesn't have an independent existence. This has to come together with either, it's an operator, it's not a vector. It's operator, vector operator. So it has to come with a gradient, with a scalar, or dot product with another vector, or cross product with another. Mere del is an imaginative. So I would like to explore one further imagination, which is also needed for us in the next, that is potential. So I hope that this divergence concept is very clear, and the divergence theorem. So del dot D is equal to rho V. So the divergence theorem states that the surface integral of a vector is, for a closed surface, is equal to volume integral of divergence of a vector. That is over a closed surface. So D del dot D over a volume integral dV. When I say V here, I need not show triple integral. Over the del dot D dV means at every place there will be different rho. So small volume around that into rho V over a closed or a volume is equal to D dot ds over a closed S. And what this indicates? Closed surface. This is divergence theorem. The surface integral of a vector field over a closed surface is equal to volume integral of divergence of that vector field over the volume closed by the surface. This del dot D is actually rho. So what is the D dot ds is equal to charge enclosed, that is Q. But what is Q? Only Gauss law. D dot ds over a closed surface is equal to Q. But what is Q? Q is over a volume integral rho V dV. Is what is total charge? If in this room some charge is there distributed in uneven manner, so small volume, some high density in that volume. Another means if I divide this into 8 parts, then each further 8 parts. लक्षात आलं का? या रूम मध्ये काही Q चार्ज आहे, तर तो Q पण कसा आहे माहित नाहीये. मग काय करायला लागेल, मला रूमचे 8 भाग केले. या भागात चार्ज डेन्सिटी किती आहे, अजून 8 भाग, प्रत्येक 8 8 8 असं करत गेलो तर इफ आय डिवाइड, म्हणजे समजा हे क्यूब आहे, 100 स्ट्रिप्स केल्या, 100 गुणिले 100 गुणिले 100, 10 लाख छोटे क्यूब तयार होतील. आणि मग प्रत्येक छोट्या क्यूब मध्ये चार्ज डेन्सिटी सेम आहे असं गृहीत धरू आपण. आणि लक्षात का, एका ह्याच्यापेक्षा सोपं जगात कुठे नाही. लेक्चरला न बसणे प्रमाण कधी मिळेल, ह्याच्यापेक्षा सोपा व्हिडिओ दाखवायचा, लेक्चरला तुम्हाला एक्झाम्पशन मिळेल. ह्या रूमचे 10 लाख तुकडे, एका क्युबिकल रूमचे 10 लाख स्मॉल क्यूब मध्ये डिवाइड केलं आणि एका स्मॉल क्यूब मध्ये युनिफॉर्म डिस्ट्रीब्युशन आहे असं गृहीत धरलं. रूमचा व्हॉल्यूम व्ही, टोटल चार्ज क्यू, पण युनिफॉर्म नाही. मग 10,000 क्यूब मध्ये, 10 लाख क्यूब मध्ये, पहिल्या क्यूब मध्ये काहीतरी रोवी आहे इंटू द टीव्ही, प्लस दुसऱ्या क्यूब मध्ये दुसरा रोवी त्याचा टीव्ही. हे 10 लाख नाही, 10 लाखच्या अजून पुन्हा प्रत्येकाचे 10 केले, असं पुढं 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 करत गेलो तर टोटल चार्ज इज इक्वल टू, म्हणजे टोटल चार्ज इन क्लोज व्हॉल्यूम. सगळ्यात सोपं, एका रूम मध्ये किती चार्ज असा प्रश्न विचारला, आपल्याला माहित नाही आहे. ह्या रूम मध्ये किती चार्ज आहे, तर अगदी सोपं तर सांगू शकेल प्रत्येक जण. ह्या रूमचे 10 लाख भाग केले, 10 लाख स्मॉल क्यूब केले, तर ह्या रूम मधला चार्ज किती. ह्या सगळ्या ह्याच्यापेक्षा बघा, आता ह्याच्यापेक्षा सोपं म्हणजे मी माझ्यापर्यंत प्रयत्न करतोय तेही मी आता हे परत सांगतो, मी आता जमिनीत गाडून घेत सरपटायला लागलेलो आहे. त्याच्यापेक्षा सोपं मी गाडून घ्यायला लागेल, ते शक्य नाही. या रूमचा चार्ज किती, 10 लाख. या रूम मधला चार्ज म्हणजे या रूमचे 10 लाख छोटे क्यूब केले तर त्या प्रत्येक मध्ये किती चार्ज आहे तेवढा चार्ज. हे बरोबर आहे. मग आता प्रत्येकात किती चार्ज आहे, तर प्रत्येकामध्ये चार्ज म्हणजे प्रत्येकाचा चार्ज ही टोटल बेरीज, प्रत्येकात किती चार्ज. तर आपण असं म्हणलं की तुकडे इतके स्मॉल आहेत की त्यामध्ये जणू काही युनिफॉर्म चार्ज आहे. पूर्ण रूम मध्ये नाही, एखाद्या छोट्या 10 लाख स्मॉल क्युबिकल जे क्यूब्स आहेत, स्मॉल क्युबिकल्स, तर त्या 10 लाख प्रत्येक स्मॉल क्युबिकल मध्ये युनिफॉर्म चार्ज आहे. पहिल्या क्युबिकल मध्ये युनिफॉर्म चार्ज डेन्सिटी रो V1 आहे, रो V1 इंटू dV1 किंवा डेल्टा V1, रो V1 इंटू डेल्टा V1. हा काय झाला, पहिल्या क्युबिकल मधला चार्ज, प्लस रो V2 इंटू डेल्टा V2 प्लस रो V 10 lakh is it right? So this is equal to Q is sum of small cubicle charge in small cubicles, and charge in each small cubicle is equal to charge density into volume of that small cubicle. And our process of subdividing into small cubicles is unending. Our process of subdividing the cube into small cubicles is unending. Every time I divide it into 8, each time, and I don't stop. हे 10 लाख ऍक्च्युअली चुकलंय, म्हणजे 10 नाही करत आपण, 2 करत होतो. 2 लक्षात लगा, ही रूम घेतली, one plane in the middle, one plane like this, and so what that does, one plane like this here, one plane like this here, and one plane like this here. You divide into 8 cubicles. So each cubicle, further 8 cubicles, further 8 cubicles, further 8 cubicles, unending. So summation would be rho, and as it is unending, this will be infinite sum. This is reflected by limit of sum. is integration? Limit of sum. So rho v dv over the entire volume. This is the del dot d, because it is rho v. Volume integral of divergence of vector field in that volume closed by surface S is equal to surface integral of that vector. So I think I tried my level best. Beyond that, if it is not understood, then let us hope that you will automatically understand it slowly, as it is just like, again, a real-time system is having some inertia. So automatically it will have its own impact, and when you re-look at the things, you may understand something on its own. So still the concept of, so here del operator was introduced in a different context, so you might have understood something, but that doesn't give an immediate sense. Now listen very carefully. We are going to, after this, we are going to the concept of electric potential, that is gradient of electric field. Prior to that, the concept of gradient I would like to introduce in a very, what I say, most simple manner. Most simple. Try to listen very carefully. Beyond this, again you show me a further simpler video and you can get exemption for the lecture. That you might have performed some experiment maybe in school days of a copper rod. A copper rod is there, and when I say rod, it is assumed that the other dimensions are negligible and we are talking only on one dimension. And at one end you are heating that rod with a spirit lamp. With a spirit lamp you are heating that rod, and the other end of the rod is open in room temperature. So what will happen? Over the length of the rod, if you measure temperature T, I am deliberately using the word capital because otherwise small t you may confuse with time, and this is x direction we say, then what will happen? And if it is origin, so at given point x there would be different temperature. And as you move away, the temperature will drop down. As you move away, the temperature will drop down. And what will happen? It means now temperature is a function of distance from the, agreed? Temperature is a function of distance from the origin. But it's not a linear function. It's a very complex function. So what you can say, you can define for how much distance, how much means here at this point there may be 200 degrees. At 1 centimeter it may be 190 degrees. At 2 centimeter it need not be 180. It need not be 180, it may be 178 degrees. At 3 centimeter it will be 163 degrees, like that. Are you getting me? So it is not linear. Temperature is dropping but not linear. So if you plot a graph, of x versus t, this one and this and this. If it is goes too long, then it will be almost like room temperature. So this is, that is the manner in which temperature falls as a function of x, this is called as d. So what this curve represents? Actual curve dt by dx, right? Is not same, it's not straight line. So dt by dx varies as you vary. dt by dx. So what you will, how you will find, if you know dt by dx, a temperature gradient function is given to you. It will be some exponential function, some function is there. And if you are given the temperature at one point, how you will calculate temperature at other point? If I tell you at origin O, at 5 centimeter, say temperature is 130. What would be temperature 6 centimeter? If temperature 5 centimeter is 130, what would be temperature 6 centimeter? So if you are able to tell, it is a very simple question. If temperature at 5 centimeters is 130, what would be temperature at 6 centimeters? Or in general, I have got 2 points A and B. What would be TB minus TA? What would be T minus TA? This is something which you must answer. What it would be?
dt by dx into xd minus xa.
So at least, even though the answer is not correct, the approach is right. So can you correct it now? TB minus TA is equal to, he says, dt by dx into B minus A. Is it you want to say? So now you correct yourself. So this is important. See, otherwise all derivations and all that things you may be able to remember and reproduce in the exam, but that is not the purpose. When your answer would have been exactly correct,
When A and B are nearly equal.
means
Distance between A and B is very less.
it is now, it is not very less, it is substantially large. Then what will you do? Even if the distance is substantially large, still your answer would have been correct if
Gradient is constant.
gradient is constant. If that is that you have understood very properly, that if it was like this, then A and B, so gradient is negative here. So TB minus TA is equal to this B minus A into this slope. So TB will be less than TA because this slope is negative. So TB is equal to TA plus dt by dx into b minus t. That would have been correct if the slope was constant, that is, slope is gradient. If the graph is linear, representing a constant slope, this was correct. But now it is not so. Then what will you do? यालाच पाहिजे. That now the problem is, this is not constant, it is like this or anything, and I am here A and B. Hello. So, any clue? So that is the direct, means you jumped, it's not a clue, you directly jumped. So actually how do you do this? Divide this into multiple small, not cube. We are on line, 2 dimensions below. Divide this into large number of strips, total number into n, and this is delta x of large number of strips of substantially small dimension delta x. Then I can say that during this small range the slope is constant. So it is dt by dx 1 into delta x. not delta x1 because delta x is same. dt1 by dx1, dt by dx1, right? This is for entire one. Plus till right, and this is limit of sum dt, that derivative in that small plus small. As delta x tends to 0, this summation goes to integration as integration dt by dx into dx from a to b. From a to b, right? dt by dx from a to b. This is here the question of we simply say the temperature falls over the line, temperature gradient. Now instead of this rod, if you take copper plate, and at the origin, at the middle of the copper, listen very carefully now, and at the middle of the copper plate you heat it by flame, what will happen then? At the midpoint, that is origin, it may be 200 degrees, and on all sides it will fall. On all sides it will fall. Then how will you write the derivative of the temperature over the plate? How will you write? Are you getting me? The independent variable is position and dependent variable is temperature. Independent variable is position, dependent variable is temperature. So how will you write? And now if you are at one point, from there if you go to other point, how it changes? So rather than, means now you will find not one derivative but multiple derivatives. How? You move from a point, you move in x direction, and you can move in y direction also. So you will find out delta t by delta x and delta t by delta y, right? And then, so delta t by delta x is the derivative or temperature gradient in x direction. Further, we can enhance, instead of area, if we put the spirit lamp at the middle of the room, now there is no need of copper plate. Even the ambience can serve because there is air material. If you keep the spirit lamp at the middle of the room, what will happen? There will be three directions in which temperature will fall as you move away. So when from one position, when you move at the other position, if you, so what would be the, now you tell me, if you are at point A, if you are at point A in the room and point B, what would be the temperature difference? TB minus TA will be equal to, how will you write? How will you write that? Or, to be very precise, if you are here, then what would be the gradient of temperature? listen, it's very interesting thing. If so, there is a room is there and the street lamp is there at the middle, and I am at this point. When I am at this point, from this point, I can move in the range of say delta R. Yes, I am not deliberately using the word X, Y or Z. From this, if I move by a distance, not unit distance, very small distance, and answer this question very carefully now. If I move by, when I was on the line, the lamp was one side, so movement was either towards or away. Movement was either towards or away. So that was presumed when the gradient, that is the gradient was a vector that way, but since it is away or towards, otherwise there was no movement. For area I skipped, and now we go directly to volume. I am here, the lamp is here. So from this at this point, if I make an infinitesimally small displacement delta R, if I make an infinitesimally small displacement delta R, what will be the temperature difference delta T? I am at a point P. I am at a point P. At point P, temperature is T. At point P, temperature is T. From point P, I make a small movement by distance delta R. What would be the temperature at that point, which is away from P by a small distance delta R? What that would be? When I am here, the lamp is in the middle. I am here. So when I am moving by delta R, the question is not complete. Why? Because by delta R, I can move in any direction. अच्छा लगा? Cube is the lamp is at the center. I am here. From here, I can move a delta R. I can move entirely in the direction of lamp, entirely away from it, or orthogonal to it, or to some extent towards it, or to some extent away from it. So, what is temperature gradient? What is it? When I stated for the lamp, it is the ratio of temperature change with respect to distance change. Temperature gradient, ratio of temperature per unit distance for a small distance.